Oh, it's about enhancing the human robots collaboration or HRC in the cyber physical or CPM as some new abbreviation which is coming and systems. First of all, the aim which we have is that we want to examine the methods which we can to improve the collaboration between the HRC and CPS environment. Before starting that, very brief, I will talk about my lab. That we have one lab that we call it RAD, and these are some small achievements that I have here today. Some of them I didn't bring. I have 2 patents, 12 copyrights, 3 books that they are published, and this one, as the last one, is by the CRC. Is the first book which is working in the robotics and Unity and embedded system. This is not something that I tell them. CRC written on the cover of the book, that first book of this time. This is the work which I had during the COVID time that all of us was in isolation. Then I write the book. And always I don't have the good memory about this book, but there is one. The second thing is that about other localization, and first is about the hardware. So on, this is my lab. Later you can follow and even see some demonstration which we have from the match that we attend, and also the copyrights, patents, and research work that we have done in our groups, and this is my personal. Okay, before starting the talk today, there is one nice sentence that I like it from one reporter, Joanna. He said about the importance of the AI and now how this AI, we can say, kill the life of us, we can say. Because he said that if I wanted that AI do my job and then I will enjoy, means that he will do the laundry jobs and washing the dishes, and then I can do the arts and also writing, but now it's become changed, especially after this ChatGPT. This is before starting my talk. I want that we review just 4 cases, then we can go to the slide. Second things that I want to say that we have 3 or 4 cases which nowadays it's become very before, and then we have and can follow the pets and also send some nonsense to the owner. And another observation that was really this number that we have to put it up in the external. Case is something that it may be maybe interesting for you, but it's again shows the first sentence that I said, that the first painting arts by the robots, it's sells by $1.8 thousand. You say 196,000. That was the painting that drawn by the robots, and then they could buy it. All of these things will shows that if we don't restrict, not exactly restrict, we don't have some good rules for the AI and especially this ICT aims which we have, later we will have more problems. Then before doing all that problem later, today we should have some activity like this ICT which we have that can have some good restriction at least for the later target of the AI. As you know, these jobs that I told you can be from the industrial and robots target, means that which and also humanoid robots exploits and also drone hijacking. These are the main targets for the hacking and security which will be made. The four cases that I show you, all of them are related to the security problem which will happen. Then with this introduction, let us review some words together. Because the aim of our meeting was to establish and talk about the means that security and CPS. Initially, I bring some definition for you, and then at the end, we will go for the lesson. First is that the CPS that it's stand for the cyber physical system, and we know it as somehow the new generation of the manufacturing system, which can combine the physical systems with the advanced computing network and software technologies. With this environment which we will make, we have some part like the sensors, we have some part like actuators, then all of them should give the data to the network part. And through that, we have some cyber environments which you can make the models, you can have the reasoning, and some decision makings will come. Then through that, you can have the feedback, come back, and then again have the loop. All these CPS jobs have the rule to integrate the computation, networking, and also some physical processing, which delivering the control for the physical process which we have. And the aim for all these is to have some flexible and intelligent agent which can work for us to do the task that we have. There are some key components in the CPS that if we list them and we want to initially talk about them, we can talk about the sensor and actuator, as I tell you, embedded system one. Obviously, when you have the embedded system and sensor, you should have some network and connection between them. Then, if you have the data and embedded system, you should have the processing and analysis for them. And finally, for the aim of the package as the CPS should be something like control the system, something like conventional controllers like PID or state machines or any other type of the controller can be the key factor. Along with them, because they are working on the area of the networks, then we need some cloud and edge computing parts. And then as the main part, which will be the more concern from our society, is that the cybersecurity mechanism and physical components. And finally, because we should manage the consumption of them, we should think about the energy management for all this part. Then if I want to talk about the architecture of any CPS, we can divide it into the three parts of the perception layer, data transmission, and also application layer, which, for example, for the perception layer, it can be some physical networks and device and sensor, as we said. For the transmission part, we need some transferring the data, especially from the sensors part to the cloud. And as the application layer, we should have some AI model and digital twins and physics system and provide the interface for the control decision. About digital twins, Professor Bashir will talk more. I'm sure then some of the parts that I bring, I will try to make them brief because it's his specialty. And I know that he will talk better than me regarding this part. Let's talk back about the capability for the CPS. We can have the autonomy in the design and continuous and real-time communication, which will be more highlighted parts. For example, for the autonomy, we are thinking about the intelligence, which we can have some advanced algorithm that we can have. The accuracy, which we are searching for the precise operation, and some responsibility that we want for adopting the sweeping for emerging the dynamics in real life. And then from the continuous and real time, we can have some enabling performatic design, which can give us the standard middlewares for the small integration part. There are two more points, like scalability and security, which again can acting for the physical systems capability or cyber physical systems. And especially for the security part, we should think more as the 4 case that I showed you. There are some parasitics nice graph, which is I found from one of the paper, which in that it will demonstrate most of the part of the CPS very nicely. Later you can refer to this paper and read more about the CPS characteristics part. Okay, then especially about the role of the CPS in the manufacturing, which is my main target, we can see the CPS can have the action for the some physical components. Maybe you are here about the Boston Dynamic robots, which we have it here. And also some reality capture or UAV and human, they can be the more demand parts from the CPS. And from the other side, even you can see the AI and user interface one, extended reality and cloud database, which all these can be the components of the CPS in the especially for the manufacturing. What we really want from this part is that we want to enhance the entire manufacture that we have by enabling the real-time data exchange. And also we want to improve the chain of the visibility, the supply chain visibility, and also give the manufacturer to have the quickly adopt the demand change and also manage the inventory and optimize the logistics. Maybe these 4 or 5 keywords that I make it will shows how this CPS can help in the manufacturer better. So from this graph, we will see that from the manufacturer side, and also thinking about the CPS, there are the different area which can help us. Suppose for logistics part, from the working and environment working, from the global operation, sales part, and so on. They can be more and more interesting part. But there are 5 highlighted points that CPS can help to have the better in manufacturing environments. First is that the efficiency can be increased with the help of CPS, and then, for example, sensors and a smart device that we have can collect and produce the data better for us. For the productivity side of point of view, we can help the manufacturer to increase the productivity and improve the process which they have. For the flexibility, we can have the CPS, which can help us to have the flexible response and change in demand. Suppose we can have some database from the product, it shows the error, and then based on them, the manufacturer can have the even better in the design of the shape, performance, and so on. And then obviously, with respect to the better quality, all these data and model in the CPS can help us to have the better quality part, and also we can improve the safety process of the automation, especially as we know automation can work nice in the hazardous area and environment, then it can help us to work better. So this brief shows the 5 aspects which can help us to use and maybe force us to use the CPS later in the industry part. Then we can talk about some challenge which we have for the CPS in the manufacturing, which are listed here. We can have high implementation costs from the CPS, that as the persons that we want to make some standard or write the standard, we should think about the expense as also the techniques that we are going to use. Then finally, the technical complexity, which highly technical system requires some special skills, then we should take about these points. Data security, which will be one of the main issues that we have, and day by day we can say it's going to increase. That will be the one point. And place to protect the data systems. It can be one of the another aspect that we should think about CPS part. There is one chart regarding the transferring the data and jobs for the CPS from the papers that I bring here. Here also we can see the different level of working for the CPS part. Yeah. There are some case studies that people are use CPS in manufacturing. Suppose from the Siemens and for example, first for the Bosch company, they are using that and then they can increase the production efficiency and improve the quality of them. Then from the GE, they use the CPS that can reduce the cost of the production of the engine while improving the performance and reality. There are some use of CPS in the BMW companies, which they can optimize the production process and improve the quality of them. These are the case which is proof by using the CPS in manufacturing and shows the nice effect. And finally, with the Siemens also, they could can increase 4,000 employment by 2.5% to 5% annually, just to have the CPS for the automated process and the beneficial and the cost which is bring from the CPS for them. But there are some challenge for the CPS part. That first is that complex system modeling, communication performance, and time synchronization as the three main major parts, which is even listed in this two review that I bring for you. Suppose for the complex systems, we can compromise the requirements components and which we need for each subsystems, and also for the communication part in the wireless network, dynamic factors and such other parts which can we should consider as the challenge part. So as the next part, we will fast review about CPS, Industry 4 and digital twins. As you know, for the Industry 4 as the fourth generation of the revolution in the industry, we are seeking for more automation, and also the role of the CPS will be monitored more. This is started, we can say now we are in this age of Industry 4, which can help us to enable the same configuring and adjusting and also optimizing environments, which can help us more flexibility and cost efficiency for the environment that we have in the industry. You know that Industry 4 can act with different area, as I showed here. Suppose for the AI part, for the cloud computing, for the big data and augmented reality, blockchain, and so on, these active in different areas. We are focusing with CPS, we can say most of these points which we show here. Then by using the Industry 4 in industry, we have another concept that we should think. It's about digital twins part, which we know it as the virtual representation of the physical object and the process that we have. And with the help of that, we are going to demonstrate the behavior in the real time. We can have the supports for remote monitoring. We can facilitation of the innovation by enabling the virtual prototyping. We can increase the efficiency. We can enhance the predictive maintenance and also improve the decision making with the digital twins part. This part, Professor Bashir will talk more, but just I very briefly will compare them from some review paper, which we can say that if we have the virtual representation of the CPS, we can call it DT, and then here we have integration of the physical components and computational elements that we can call it as the CPS part, and the scope of that will be focused on some individual entities or system. But here we have the broader system comprising multiple components. And with respect to the IoT part, it relies on IoT, but with the CPS, it uses the IoT to connect the physical systems and so on. Example, we can have digital models of the jet engine that they make, but for the CPS, we can have some automated factory lines, which can optimizing the line factory and so on. There are lots of benefits for the digital twins, especially for the simulation of the challenge and centralization of the operation, which we can make with that, and we can solve some of the industry problems with that. There is just one conflict that we can say about CPS and IoT, that maybe this figure will show the difference between the IoT and CPS, that maybe people will ask about it. The IoT, as a written here, it is going to enabling the interaction of the diverse device through the internet. But CPS is bind computational and control components with the physical system forming an foundation for the IoT part. Then we can see that the CPS can cover the IoT part. There is one table that I bring here. It maybe shows better this difference better. Is that with CPS we are integrating the physical and computational system, but with the IoT we are connecting the device for data exchange and remote control part. From the autonomy part, we have the high autonomy with the feedback and decision making in the CPS, but with the IoT we have less autonomy, and somehow we need some external control system which can help us. There are some key components in the CPS, suppose real-time and actuation we have, but for IoT we have network connectivity and data communication part. Then as you will see, the CPS can be active in different area. It can work in the manufacturing part, can be in the smart cities, can be with IoT device and robotics parts. And then we will go for the main topics which we have as the HRC, or human robot collaboration with the help of CPS. This HRC is nothing but interaction between the human and robots work together, which they are going to work closely to align to do the specific task. And also the rule of that is that going to span the various domains, enabling the innovation, safety, productivity, and also enabling the robots to become the interoperable collaborator in diverse fields. Means that we are going to give some autonomous behavior to the robots with the help of HRC parts. The importance of the HRC in the manufacturing can be from 3 points: of improvement of the efficiency and reduce the error, and also increase the safety in the hazardous tasks and flexibility of the complex work flows. In one line, if I want to tell you about the HRC, we can say that the robots can assist the human to enhance the task performance, and then we call it HRC. There are some key technologies which is driving in HRC, and especially with respect to the CPS, that we can list them here. We can think about the AI part as the artificial intelligence, IoT and sensors, which the aim is that to have the real-time monitoring of the humans and robots action. We have digital twins as the simulating the human robots, and advanced robot which can be have the collaborative robots that we call it cobots, and designed for the safety parts and improvement with the peoples. Some key roles for the HRC can be listed as 6 points. The point number 1 can be enhance of the productivity, which based on that the robots can do some repetitive and precise jobs for us. Safety can be especially for working with the cobots or collaborative robots, which can reduce the human exposure, especially for the hazardous environment, and skill augmentation, which can have some precise tools or sensors that can amplify the human's capability more and more better. Three more points can be listed as flexibility and adaptability, innovation in problem solving, and training and assistance, which based on that, suppose for the flexibility, you can have some human jobs and robot consistency as the HRC can allow them to work with each other to solve the problem better. And then for the training also, it can train and assist the humans better to do the jobs better. 3 points can be listed as the benefits of the enhancement of HRC. One can be for productivity, for safety, and for employee. For productivity, it can reduce the cycling times that we need, especially higher output with the better quality part. For safety, it can be lower risk for the workplace and safer handling. For employee, it can reduce some physical jobs and also cognitive workload for them. Then how we can think about more these points I bring here with some example. Suppose robots can do some repetitive jobs for us with the less number of the errors. Then in automotive industry that you can place some bots, it can work better. Higher output with the consistent quality is that it can reduce the human error, and especially when the work will be repeated by the human, some error will happen. This can be omitted with the help of good HRC. So, for example, electronic production, robots can do the assembling jobs much more better with the better HRC. And then for the safety, for example, lower leaks, which will happen in the industry and environment, which we have with the help of cobots can be come to pictures, especially for the warehouse robots environment. Robots can carry very heavy loads, and the risk of the injuries can come down. And safer handling, for example, in the pharmaceutical, robots can assist the sterilized processing for making the medicines, for making the vaccine, or any other parts. It can be much more safer environment for us. With respect to the employee, we can see that it can little bit reduce the workload of the humans, especially when it's need some decision. It can help us to do it much more precise if it's planned proper. Suppose they can do the repetitive assembly tasks, which can, after that, workers can just think about the quality and the process of the optimization. And some opportunity for skill development, for example, they can train by the workers to do the jobs from the very expert people, and then so many robots can work at the same time to do the work with the proper skill, which maybe if we want to train 4 and 6 person, it will take more time, but with the help of these methods, we can copy the behavior of the persons better with a more number of robots. We can think about application of the HRC in different area. I listed 6 and 7 one from some recent paper which I found. For example, in the healthcare, especially for the patient mobility and elderly, we have some good case that they can work. You know that for the next generation, we have the lots of old people that they need the robots, especially for Alzheimer and Parkinson disease, which will be increasing the work. Then one of the point that even in our standard, we should think about it, it's about the healthcare area, and we should talk more and elaborate this part in our standard part. So is that for the manufacturing that they can increase the efficiency? It's proof, there is no doubt for that. For logistic parts, for taking the loads, Currently, we have them in most of the hotels as the concept of the service robot. In the agriculture, we start to using for planting, monitoring, and harvesting the crops. Search and rescue, we can find them, for example, in the case that there is some avalanche or there are some earthquake or any unwanted environment, which during the war, they are searching for the people, lost people, and so on. It can be the one good application that we can think about the HRC, and I wish that through our standard we think about especially research and rescue, and rest is that about the healthcare issue which will happen later. Then we have some challenge for this HRC part. First is that human-centered challenge. First is this, that we should think that people should trust on the robots. These years it's increased, especially after the COVID time. I can say one of the benefits for the COVID was that it increased this level of trust to the robots, because they enter to the environment that people they avoid to enter. Then robots go and do the jobs. You will see now most of the hotels nowadays have lots of robots that can help and assist. This showing the robots' trust between the people. And then ergonomic concentration means that the size of the robots, shape of the robots, behavior of the robots, that it should not kick the people, it should not have the collision between the people, and so on. That is the other issue. There are some technical challenges which we have: real-time communication and coordination, which we can say with the help of Islam tag, and ROS. Nowadays, it's become much more better. Even we have some deep method for analyzing the environment, reading, and so on. It will help more and more from this technical challenge. And some integration issues, something like compatibility of the robot with latency systems in factories also. This is one, we can say, three main aspects that we should think about it and have them. About this point, I thought, okay. Now we understand about the HRC part, we understand about the CPS and it's important. Now let us see how we can increase and enhance the HRC in CPS. Suppose to improve the communication interface, some gesture recognition, voice command, and wearable device will be more helpful. We have some case that, for example, for disabled people, they are using the robots that can give the commands and robots can follow them. That was successful scenario. Or advanced robots that nowadays they are comes with the help of the AI and advancement which we have with the AI. This is the another method that can help us. Some real-time monitoring that with the help of AI, which day by day it will increase. We can see the nice task guidance through the robots, and safety mechanism, some proximity sensors and collision like LIDAR, like Kinect, like other sensors which is come to pictures nowadays. We have very nice anti-collision, so we can say, system which can help us to have the better control. Training and simulation also can be one of the better methods for enhancement of the HRC. Training with some specific location. First, we should work with some local place, then we can extend the job to the more and more complex environment. Can be the nice jobs, we can improve the HRC. Currently, if we can see that in restaurants, robots are working very nice, because they are trained more and more time in the restaurant environment. They know the obstacles, they know the location, they know all the issues which will happen in the restaurants, and now we can see the movement of them. Then transparency and exploratory means that, for example, for the design robots that can explain the decision and action to the human collaboration, it can be one point. Suppose robots can inform the people that I want to do this, and then take some acknowledge from the people, and then do the jobs. It can bring the trust and also help for more enhancement for the HRC. It means that for some level, we can have the autonomous movements from the robots. For some degree, we should cut it, and then after confirmation, they should do it. And advanced sensing and ethical and inclusive design, which will be much more concerned. These point number 8 and especially point number 2, point number 7 are something that I think again in our industry we should think about it, and in our special standard development process, we should focus on that and think about the validity and make some better solution, which in future we should not have some problem. Let us see some case study and future trends that we can have. We have, for example, about the automotive industry, we have the cobots or co-robots, which they are going to help each other to do. How it will work, it can going along with the human workers, just help the workers to pick and place the boxes better, and do it something like screwing bolts, which need the more power, or maybe that worker become more tired, then it can work better. It can increase the production, it can reduce the work fat and also injuries, and can assist the workers better. As the next case, we can see for the healthcare company, suppose with the medicines manufacturers, or they want to make the vaccine, or they have some sterilized environment, they can nicely work and help the people. They can enhance the hygiene and sterility in the operation, and they can streamline the workflow with the faster and effort production. Suppose if you remember the COVID times, that all the worlds they are waiting for the vaccination and vaccine, then the manpower was less, and so many in the medical industries, they want the workload. If we have lots of robots that they can work in that time, then the making the process for the vaccination was more, and maybe we could cut the corona time maybe much more faster than what people have done. The next case is that the case that we can see is for the electronics production, which can improve the quality production for that, which in this case also you will see that they can have the higher precision tasks, then with the help of using some visual inspection and fine-tuning jobs, they can work. I bring one movie from IEEE Spectrum, which in that it shows that especially for the vision part, suppose when they want to make the PCBs with 6 layers, 7 layers, how they can make the process of making the electronics device better, faster, smaller, and more reliable with less number of costs due to the manpower and other factors. Here you will see one example that they are using as the cobots in the smartphone assembly, and then they will do lots of tests with that. So as the future trend in the HRC, we can see the AI and machine learning integration, which will be more and more, especially from most of the paper. It's mentioned that we should enhance the adaptability and efficiency in the collaborative tasks, which is a start, and we have lots of swarm robotics jobs that's coming. Then cognitive CPS, that it's going to improve the workflow and efficiency and reduce the cognitive loads for the human, and remote collaboration, which mainly they rely on the two words of augmented reality, and VR or virtual reality, which can helps to control the robots from the remote location. Then we can distribute the manufacturer place in different city, and each part can do very nicely, but coordinate with other plant, and then finally one line can be the production. Then no need to focus and have the big area for one product. We can split the production line in different location, and then combination of all can give us the production better. Ethical and legal consideration also should be that we should think about ethical challenge and defining the legal framework. Ethical, especially when it's come for the elder people and children, something that we want to work, or disabled people. We should think about this point that they should not kick them, they should not. I show you one case that one small robot is going to say the bad words to the owner or following the pets. It should not happen. This is something that, especially nowadays, we don't have any point for any standards of the robots. I mean that the robots' behavior, still we don't have the rule. I wish that in our standard can think about this point also and improve this point. Then emerging the trends will be for the autonomous tasks through the AI, improvement of the NLP and gesture-based communication, robust training tools using the VI and AI, scalable architecture, and with the help of all, I wish that we can have the better HRC parts. The enhancement for the HRC will be in three aspects. That first can be improve the efficiency and safety, then it can be enabling the greater flexibility, then ongoing research and innovation. These are the 3 points that we can think about the HRC part through the collaborative job with the humans and robots, through the advanced communication and safety, and also finally can have the better innovation part, can help us to make the better HRC part. That was the main aspect regarding the HRC part that I tried to review fast, but we will share this PPT for the participant later. You can read it better. The main aim for this talk was that you become more clear about the concept of CPS, CPM, IoT, digital twins, and HRC. And later, if you want to help our committee and standard groups, with this respect, you use them in your research and also give your idea regarding that. Thank you so much for your time. I wish we didn't talk much more.
Thanks to Dr. Atta for this very impressive report. So, any questions from the audience? Yeah, if no, I want to raise a question.
Please.
Maybe to the public, I mean the ordinary public, the most famous robot is the Boston accident.
Yes, exactly.
And recently, I noted that it has realized fully autonomous.
Yes.
It can, it doesn't require any plans or designing for their job. They can work fully autonomously. So, do you think? How's the current development status in China?
Your question have two answers. One is that if I think from the researcher part, it's very nice. If I say it's very good that it can work from research aspect, as the researcher, I prefer that it will work autonomously, no control, it do all the things.
Yes.
It's very good. But from the other side, means that from the human life, maybe it will not be good because later it can use in the war. Maybe it can use for some, if it will be hacked or if it can be influenced by other factor, then it can do something against the human.
That's
okay.
True.
The main things, that when they make the robots, initially, there is one first rule that Isaac Asimov written that. He said that robots should not be ever clever than human.
Yes.
That was the first definition for the robots. But now we will see that it's going a little bit to be clear. Boston is great, but we should also think about some method to restrict them. Okay, maybe we will have later some rules for the robots, like human. If now you are passing the traffic lights, you will have the fine. Maybe after some year, we will have some rule for the robots that you do this job, then you should not work. Like this, it should happen. And I wish that in our standard also, at least we open some chapter through these ethical jobs, which can help future of the robotics better. Okay. Still, I believe the first sentence that I bring, AI should make our life simple, not do our jobs. Okay. And I wish that we will have them. We are very happy that we have ChatGPT, but you will see that all the students copy paste. Okay. Now we couldn't find the solution for them. As the teacher, I will tell you. There is no solution. A student will do. But how we can check when they will come to the exam, we will say that all the marks are come down. Okay. Then the quality of the teaching will be affected by the AI soon. In less than 5 years, we will have so many educated people that they don't know the math proper because ChatGPT will do it. They don't know a statistical analysis because ChatGPT will do it. We should have some ethical. Thank you so much.
And yes,
Please.
do you think it is anticipated that one day eventually there will be some malicious
Of robots.
Yes.
It will have no problem. From that point, I don't have problem. If the robots will come and defect the countries at the defense part,
Yes.
it will be okay, that human will be safe. But if one day, there is one famous movie is AI, it's very long back movie. In that movie, the robots have the protest against the human. I think it will happen soon. Okay, we should be ready that one day one robots will come and knock your door. Okay, sure.
Yeah,
Thank you so
thank
much.
you so much.
Okay,
Okay,
sure.
thank you, Doctor.
Okay, thank you so much.
And now we have a tea break first,
Yes.
and before we
Sure.
last period.
Okay, good. Thank you so much.
The tea break has been ready outside. I will also enjoy it.
Thank you very much. Did I talk about? I need to go.
No,
It's
very
okay.
perfect. Yeah,
I try to.
You are a town management master.
This is the
Tea break.
I have a very good colleague.
15分钟场歇时间，那我们大概50分左右回来可以吧？
My teams. And, I think,
All I need is hot coffee.
写的把那个音乐拉长放，就直接点那个音乐，缩小音乐。还会拓展额度，这边拓展。
翻嚟之後，我都會知同佢打電話，或者我會諗辦法搞掂。我真係做嘅。
那个方面这个哦。 家属。啊，我跟他们听友去说一下，这种东西是点那个谁啊？开来的是我自己，但是开的，没开，这是开过，好像小孩子没有。放回去看。不然我咱们可能别就意思，看个电脑，应该是的，对，没错。但是拿了他的第二个，然后对这问题，搞定了。好。 大家看不看清楚？我们家都是一起的。我就看不到。这样。但是我跟他的联系，我们经常是属于那种是跟别人联系那类的，他是福建，他是他走艺术型，一个字。也是电商的，对，我们就电商，然后有些考公。你是什么专业？文化产业啊，文化产业，文化产业管理，就算我们走。文化产业，你们在广州？对，是新广州。对，就是关州街道，关州云龙街道。那不是离上海吗？是啊，离爬车很近，都长这样。看。再看一下。两个是
First of all, thanks again for this invitation to this event. And the title of this presentation, it is about AI, machine learning, and most used for prediction of maintenance, and coupled with what we call the digital twin or numerical models. So as we explained, Esther, so I'm actually in Dowan University of Technology, working like a for professor there. He did one laboratory we call it Smart Structural Health Monitoring and Control Lab. But this work is since September, and before I was in the University of Paris-Saclay and in Paris, in France. So let's I don't know if we can. Yes. So the introduction. So I just split in this presentation. I will try to make it as not too long. So I split it in different topics. To introduction to digital twin. What is the challenge in traditional maintenance approach? AI in this kind of transforming maintenance. Machine learning, and it's relevant to the AI, how the AI and machine learning are linked together, and the predictive maintenance, with AI and machine learning, and of course, I will show some examples of applications with S and conclusion. So the points in red are really the connection in this presentation, which is, as you can see, digital twin coupled with traditional with the maintenance, machine learning, predictions, and I will show you 3 examples. One about engines, second one about building information management, and the last one about what we call crack detections using CPIs, thanks to the colleagues that present make these nice introductions. I saw yesterday we had a lot of introduction about digital twin. So I will try to go a little bit faster because I think we had very deep presentation about this. So the introduction of digital twin, it's as was explained, it is an automatic numerical representation of a physical device, object, or service. So we need to distinguish here. There is 3 parts. The first part, which is a physical device that can be also a process. It can be manufacturing. It can be engine. It can be a lot of things. And the object, it can be like a behavior of one component, and it can be also a service. And I will show you later some examples. So it can be automatic, which is also an automatic copy of an object in the real world. This is an example what we can have like managing of or monitoring wind farm, jet engine, or other large items. We can also, I will show you with some example with the city or building. Digital twin technology can be used, in fact, to duplicate a process to gather data. So I put in red the keywords, and for me the most important is process and data, because it's together that help us to build predictions. So I just showed here an example about the real and the numerical models. So here we can see that we have the real object and the numerical one that we can monitor it, the function of these generators. We can have it also for manufacturing. We can just follow this using very different software, but we just monitor the process within the plan. We have also the maintenance of airplane. Of course, we have and the monitor of the airplane, not only when it's parking, but also during the flight. And there is a lot of things that this monitor is. There is a lot of IoT sensors that we have real-time data. So we have also for the environment, we have also the automobile is the same things. We have now digital twin models, not only at the end of the manufacturing, but we can use digital model now during the process of manufacturing. We have also, of course, this wind turbine farms. We have also in the size of the city, but you can also have digital twin for just one building because it's a lot of, we deal with a lot of data. Even for one building, there is a lot of information that we need to monitor. So the digital twin, we also find it in surgery. That you can see some people, they can make operation from China, doing operation in another continent, so like 10,000 kilometers. So what is in common about all this digital twin, that's my point, is the time of response. So when you are dealing with monitoring, if you monitor this, of course, and monitor this, if you have some problem here, the time of reactions, okay, you can stop 1 minute, 2 minutes to repair. If you have a factory that dealing like 1,000 of pieces per minute, so the minute will cost a lot of money and it's huge cost. So what you dealing also for electricity, so you need to deal with, if you have like how to call it, this consumption of electricity, you need to reduce this consumption, so you need to have a time to react. So it is not a very big issue. However, when you are dealing like for surgery here, and you have a digital model for the operations, the times between you got information from the sensors and the time you react, it's very important because if you are making surgery of a brain, like a professor explained yesterday, so it is not easy to wait because every millisecond is important, and the times we cannot use always cloud. We cannot. So it depends on the operation for such things. So digital twins are very essential. It's in fact it's kind of programs, computational program that use real world data to create simulation that predicts the performance of a product process. So this kind of program integrate IoT, artificial intelligence, software, and in fact, when we talk about IoT, sensor, it is while more we have, better we can have more reliable models of digital twin. So more data, more reliable is the model for digital twin. So the advance in machine learning and big data these recent years have made this virtual model an integral part of the latest technology to drive innovation and improve performance. As a result, creating one digital model enables one to improve strategic technology trend, prevent costly failure of physical objects, and use predictive capacity, service, advanced analysis, testing procedure, and monitoring. So digital twin, it's not only for fun, but we use it for improving in terms of failure predictions, because as I explained, when we have a good prediction, we can save money for it. And also, we use the digital twin for monitoring and predictions. For this part, I will focus because digital twin is a really very big topic, and our colleagues already talk about it. I will just focus on one part, is maintenance. So I will just go with this. Let's go for this one. So I'll go directly for the maintenance, which is when we talk about the maintenance, there is a different three category of maintenance, and it's very important. As I explained at the beginning, the reaction from when we are doing monitoring from the digital model to reaction of this, or to improve or to react, it depends on what we want for the maintenance. We can have what we call preventive maintenance, which is preventive maintenance. It's some maintenance you have regular scheduled inspections, and serving to present equipment failure. So we do this maintenance to avoid failure. So there is the first one, we try to have this regularly and try to monitor like routine to check like a vehicle, for example, for the traffic, signals, communication system. We have this kind of routine check. The other one is not preventive but predictive maintenance, which here we deal with predictions. So this one we have routines, and the other one we use data analysis. To have a data comes from something which is sensors. And the sensor to predict when the components may fail. So we have a lot of data on time, and we need to transform this time knowledge to some that can help us to have or to predict when the failure may occur. The last one, it is here we switch from preventive, predictive to corrective maintenance. So here we are really at the times we already in front of a failure. We need to this is like it's also for minimizing downtime and restoring service quickly. This is maintenance. It's a little bit last minute correction. An example here for in terms of smart transportations, the maintenance, we can talk about global systems, subsystems, and local systems. If we talk about the global system, like here, about transportations, transportation include all infrastructures. It can ensure road, bridge, facilities, and all the things that allow this kind of traffic. I'm talking about transportation. It can be also telecommunication. Telecommunication would be all the network, all the antenna, all these things. So, but inside this infrastructure, we have also the vehicles that make the road. If we have one vehicle that have failure, they will block all the traffic. So this is kind of monitoring we need to monitor and to predict after that. We have also the traffic management systems in addition to the global system, the local, the components, but we have also the management systems. If you have a good software, if you have a good management, you have regulations, if you have so you can predict and make it more easy to have a smart transportation. So as I explained, all these systems, they need data. To have a predictive, we need the data. And data it comes from IoT, Internet thing of objects that are connected. All these sensors, we have different kinds of sensors. We have like connected sensors, like directly on the object, the real object. But we can have also a non-destructive object that can, like we can have laser, we can have database on image, which means it's kind of sensor, but we don't. It's image. It's data also. It's only that this data is very costly to analyze. So for data analysis, it can be like when we have the sensor, we have the data along the times. More we have the data, it can help to have better predictions and of course maintenance. This is some keywords also we call about remote monitoring, which enable continuous oversight of the vehicle infrastructure, reducing the need for frequent physical inspections and improving the response time to issue. So just to challenge for this, I explained to you this kind of traditional method for maintenance. We have like the first one we have the reactivity maintenance focus. There is different points I put in red, and inside every main challenge we have some key words. For example, for the reactive maintenance focus, which is limited by proactivity and planned repair. So this is the risk we call it for the maintenance. What can happen? So when we talk about the resource constraint, it can be, for example, the budget limitation. It can be also labor shortage. So this is the risk for this kind of that can have a problem or with resource constraint. We have also data, which means data. This is a very main problem for all the people dealing with digital models. So how are the data constructed? This is fragmented system for data integration. So this is even when we have a sensor. So depend on how these data are constructed. We have also outdated technology, so which is and flexibility, limited automations. The project I'm working here is dealing with bridge, and as you know, most of the bridges they exist more than 50 years ago, and these bridges they have sensors, they are outdated sensors, and this data it's not easy to analyze. Inefficiency channel. So as I told you at the beginning about the maintenance, so static maintenance schedule inability to adapt. Sometimes for the wind and for like offshore wind turbine, it's not easy to have efficient scheduling of the maintenance. Every maintenance for the offshore wind turbine is very costly, and we need really to be sure that we need to have this maintenance. Safety concern, which is inadequate safety check and delay response to issue. We have also limited shareholder collaboration for this is some kind of if you have inefficient communications course, we will have after problem with the shareholders stakeholder. We have also the regulation, so it's not always easy to implement this kind of maintenance if the regulations are not already implemented. So the artificial intelligence, so as I've talked about, but it is a very general word. So it is very, I call it like communication word. But more of the people using this are more often talking about mathematical application, like predictive model. So here there's some example about the role of AI. For our, it's help the predictive of the maintenance. It's make an automatic diagnostics. It's help the role of the maintenance from manual to automatic. It optimize the maintenance schedule. It's also enhance decision support. When I talk about the decision here, it's by itself, it's a really one research topic, because when you have a data, you have like a lot of parameters. You need to make a decision. You need to optimize your decisions. Decision making, it's you can have as much data as you want, but if you cannot decide, it's useless. So making decision is very crucial. So integration of various data sources. So sometimes you have different kind of data, time variation of data. You have some concentrated data. So the nature of the data is very important. Enhanced training and simulation. So you need to, when you use AI, you need really to train your machine learning. I will explain to you. It's a kind of layer inside the artificial intelligence. You need to improve this part. You have to have like user-centric approach, which is you need to put the user in the middle, and sustainability, which is something very important that AI brings to this maintenance. So let's just go now quickly to the machine learning and its relevant to AI. So the the predictive maintenance, as I explained, is advanced. It's an advanced maintenance strategy that leverages AI and machine learning to anticipate failure and optimize maintenance schedule. So we have 2 points very important. Prediction is this one, and optimize the decisions. But all of this, the optimizations and the failure analysis, it's based on analysis of data from various sources. So it can help organizing, reducing downtime, lower maintenance costs, and extend the lifespan of assets. Because if you have a factory, you don't want that your plant broke or have a problem, because the time you spend in maintenance, it's depend on what product you produce. you can cost you a few million RMB. So the key components for the predictive maintenance, the first one is, as I explained, is data collection. So the data collection is very key word. Machine learning models, I think a lot of people, they talk about the keynotes. The model is very important. It is based on this data. So if you have a good data, you can have models that you can build with machine learning. And to have this model, you need to process this data. So the data, they are very not homogeneous data. It's very mixed data. You need to sort them, understand them, make a prediction so you can create this model. So these 2 points will help you to do this. If you have the model, if you have the machine learning approximation model built, you can make a monitor and you can have a prediction. So what is the difference? So here I just explained how it works in machine learning. It's you have just input output. So if you have some data that you already know, you create this with the machine learning approximation. You create like a kind of mathematical model. Depending, it can be easy, it can be complex, but it's like input output. When you have the input and output here, it just helps you to create this model. And after, when you create a new X, I should call it X thing, to have a new output, which is kind of predicted. So the artificial intelligence, which is like I explained, this can be applied for everything. And but as soon as you have very good machine learning tools, help you to make a very good predictions. Machine learning itself are relying on many mathematical approach here that creates these models. We can talk to some people, they know more deep learning, Bayesian approach, decision tree, KNN, and so on. So there is a lot of approach. This is more mathematics, and I really come back to this word because here mathematics help us to create a model. If your model are good, you can do a lot of prediction and reliable prediction. If your model not good, you can have as much as data, you will have always wrong prediction. So when you deal with this data here, and all this method, they come from mathematical guys, we talk now about data science. So for this data, we need to understand when you have cumulative data, you need to see what is the volume. So we have not too many data, we are talking about data analysis. If we have big data, so we will talk big data analysis. And then it depends on how is the velocity of this data. If you have like data coming from earthquake tables or other very fast telecommunication, you need to have a lot of data, the variety of the data, viability of this data. If you do some testing on some robotic, you know that there is some data that's not reliable. You need to take them out and you need to make, how do you call it, cleaning. And the value of this data and the veracity of this data are very important. So the only challenge now for nowadays about using artificial intelligence, what people they don't say, they don't talk about it, is data science. It is a very multidisciplinary topic that do for visualization, because data, you have a point, but you need also to understand how they are distributed in the domain. You need to choose the right domain. You can make statistical analysis. Some data, for example, for the earthquake, you need to detect the pattern which recognize the signal of the earthquake. You can use pattern for like do my colleagues about they have the pattern for crack. You have that pattern. So this pattern is kind of signal. It's kind of mathematical models that you need to recognize. Of course, you have data processing, data mining, machine learning, and all these are really not easy to deal with it. That's why if you check the salary of the engineering nowadays, the guy who earn most are these kind of guys, data scientists. So when I was in France, I was trying to hire one guy, and it's impossible. when you hire a data scientist for research, nobody will come. Most of them, they go for banks, for company. They told you, guy, you pay me double. No way. For for research, we don't have enough budget for such guys. So that's why we still struggle. I hope we'll have deep crisis when they come back to research. So benefit of predictions and maintenance will reduce downtime of because this is very important. I just evaluate some project in the European community, and most of the people now for the project they focus on this predictive maintenance, reduce downtime because of a huge company doing, for example, with they have a machine that should work 24 hours. They cannot stop. If they stop, I don't even tell you the price that it costs them. Cost saving is not only about machine, it's also about money, people, optimize the resource for allocation, improve the safety, enhance operational also efficiency. So I will just go directly with something more funny. It's examples to understand how it works. So I will go just with the first example, which is we can find it directly in MATLAB actually with Simulink and SimLab. It's a digital tool with actually it's a pump that you can see here. We try to detect a failure, and the failure for such example of the pump, it can be like you can see it's kind of like a 1, 2, 3 shafts here, and the pump will have one axis. The idea how it's like engine of the car, how when it will break. It will break if we have something wrong, like with the shaft bearing, if we have leakage in the plunger seal, or we have blockage in the inlet. So we have this kind of failure because we need to define if I want to detect some or predict a failure or maintenance, I need to know maintenance for what. So this is the first thing, detect what kind of failure, and then try to predict it. So we have the model here. So the idea just summarize here. We create a digital model here. Of course, we need the sensor, we need data. There is two things. Either you can put sensors or not. Some like the colleague who presented yesterday, it was a sensor on the brain. So it is not always easy to have these sensors. Like you cannot put easily sensor here. So we can create what we call it a model, finite elements model, that can give me some data, and I can just update the digital models to get some predictions. So here you can see that we have from data here on time variations. We can create, so we can have like a different analysis. This is the different frequency. We can have like Excel file. We train these models with machine learning. We can develop like predictive models. With this predictive model, when, as I explained to you, we have the model, so we can put the X and have the predictive Y. So we can use it like create simulation models, and then we can implement it in directly control units. So here we can see in details, we have this, the typical failure. We create a CAD, computer aided design model for the pump. It's like 3D models. We can see the different graph chart that can because why this is a kind of failure, because the engine, it will be working as soon as this one doesn't move even less than 1 millimeter from the axe. If this axe moves even a little degree, less than 1 degree, it will still moving. If it's still moving, it will create fatigue, and it will have, it will sooner or later it will crack. So detecting this kind of defects on the crankshaft will help me to have to maintain and increase the life cycle. So here we can see also the plunger 1, 2, 3, that the variation here that we can make simulations. We have, as I explained, the different kind of failures. So, and then we create a Simulink models here with the the model here on Simulink that we we do like we can see the initial, the measured, and the tuned one. So we can do like approximation model. What else? So this is based on simulation form. Yeah. So the other things also we can see here for our models that we create, we can have different parameters. These parameters we can either activate or not activate. We can turn the parameter in our models to converge to the data we have. Here I mentioned some gradient method. Gradient here of the parameters value are calculated to determine the direction in which the parameter should adjust. This is often used for optimization method. And inside MATLAB, we just use this, we call it gradient descent method for optimization. But with advanced models, we change this from we call it heuristics or probabilistic approach, so we can have a very much more precise tuning. And especially here we use gradient because we didn't have too much parameters. But if you have a model that have a lot of parameters, you cannot anymore use gradient because it's with diverse it will not get you a very good result. So here we can see that for the defect, when we run these models, we can see like we can activate, for example, the seal leak, blockage leak. So we can have like what kind of defect that can be activated. We can see and we can just choose which one we can create. So depending on this kind of program, we have only 3. We already have like we can create 200 scenario that can create it for the digital twin models. And the idea is for this scenario, which one we need to, we can have good predictions. For the machine learning models or the approximation, we use like we run the model with Simulink. We have like often, as you know, when you use machine learning, is 70% of the data we use it for training, and we have like 30% which is split between testing and validation. This is what we do exactly the same. 70% we use for training, and the other one we use for predictions. And we had a very good correlation between the simulation and predictive models. So here we can see, as I explained before, so we have a model here, the variation in time variations. And of course, in time variation, we don't have informations. And often with time variations, like we have for signals, often we make a transformation. Which domain that give us more data? It's about frequency domain. So we use like transformations, like Fourier transformations to move from time variation to the frequency variation. And we can see that when we move to this frequency, we have some peak here, which represents the risk of defect, and we can predict this kind of frequency. So so this is very important to have this kind of transformation. So once we have this kind of transformation from the time domain to the frequency domain, we can after have, as we Fourier first transformation, and we have the classification of the default. We can directly we can just plug this, and we can say what kind of defects we can have within our model. So another example here, I just show you here, which is for electric engine. We have another model here for building information management, which is linked to the like smart city, smart building. So we can see that we need like the same. We need data, tree design, a lot of data in addition to the sensor we can put, and of course the models. So we can have also we create a digital model with predictive maintenance and operation for the building, because we can have different prediction for energy, from many things. So another, like he explained, colleagues, of course, we have also the digital twin for manufacturing and other things. So I would just, it was a good introduction for the cyber physical system model from the colleagues. So I just give you here some results about cyber physical system. This is application about to improve the landscape spatial prediction performance. As we are here in Guangdong, we know that we have lots of rain these days and lots of accidents, and so these accidents could be predicted, and it could be also we could do something. So it's not easy. So because some people, the density is very high, especially in south. So there is some place where we need to reduce or to predict the slope and to avoid this kind of accidents. So I don't want to go in details, but there is a lot of the article was already published in last year's, and there is with the colleagues in. I was still in Paris, so we keep working on this one. And the second one, it is also about cyber physical system, but this is for structural health monitoring for bridges. And you can see here we have a model of the bridges here, but in reality, we want to do on-site monitoring. We go to the bridge, and we have this camera embarked for the drones. And we go outside. We do, we have, as I explained to you, we have an image for time variations, and we use also Fourier transformation to have some frequencies. And this kind of frequency will give us idea about if there is some problem with the bridge. So this result was also published like 1 year, 2 years ago, and but also for the bridge around this Guangdong. So the recent work with my PhD student is related to the crack detection and monitoring. So for the bridge, the first example I show you with the cyber physical system, the data we obtain, it is based on signal or based on sensors. So for this part, we use image, which means we need to detect a pattern of crack pattern, and we try from this one to say, because we don't wait till the bridge collapse, we try to get this this crack at the beginning, and then we can analyze if I need to make maintenance or not. So the bridges, as you can see, there is some people, they see the bridge like concrete or steel, but if you make a digital model, you will see them like 0-1 bridges. You have like a finite element model, we have like some frequencies. So it's a lot of data for every bridges. So we can have like also this kind of bridges. We can have like acoustic monitoring. You can have also so actually how we do for the bridges is we can just or infrastructure. We can just see inspection, like we see the guy here, like visual inspections. But we call this non-destructive evaluation, or you can see by how do you call it, on the cables, on the bridges, the guy they need to climb, which is not easy, and you cannot do this maintenance every week, which is complicated, or every month, it's costly. So in the crack, we need to define if there is a crack in one bridge. We need to see, is it a cosmetic crack? That can happen, crack is everywhere. And even if we keep zooming in one wall, we will see crack. But we need to see if the cracks are important or not, if it's dangerous or just cosmetic. Okay, so we use also this kind of the drone inspections, and with the camera, and then we go under the bridge, we try to follow, so this is like we just see the front and down. Now we are working on one drone that can also go under the bridge and have a camera like on the top, so we can have like 180-degree monitoring. So the idea of the crack here is the monitor, because when we have a bridge, we have the concrete, the real bridge, but we have also the digital models. So when we get this defect, we transform it to digital model and to show that we have this model. So when we make the analysis, we integrate the defect more the behavior of the bridge will change and we can have more predictions. So we have here example. This is like a different, from the image, we use segmentation so we can get the crack. It is not always easy because, as you can say, when you have this image, this is very basic, but sometimes depending on rotation of the light, of the direction of the crack, so it's not easy to get this quick result. So when we do a crack, we can see that when we monitor the crack, for example, for one surface, for you just see like 1, 2, 3, but for the computer, you see different colors, depending on what is the size of the crack. And you say, okay, when it's blue, it's not important, when it's this, and of course, above 0.5, it will become red. So with this, we see, okay, we need to do something. And so I will not go in details because this is 3 years works. That's when we have the crack, we have a conversion neural network, we have some YOLO, and then we have like a software, and then they use some crack here, we can see. And the crack the same, we have this kind of coding, decoding, and then we have this to detect the so we can see here like when we use like some data, so we train to detect this, and after when we have this kind of very well trained, we just new image and then we can detect quickly. This takes times. When it detects times for the crack, you know, you can see here there is different crack. There is like continuous crack, there is like mesh crack, there is like a star crack. So it's not easy to have different cracks. So we have actually 6 to 7 category of the different cracking. We try to detect them on times. And then when the model is fixed, of course, it takes time. After we implement it in one run, and then we have real implementation. So at the conclusion, I just can mention that the challenge in implementation of the predictive maintenance is data quality and integrations. So the data is very important. If you have a very good data, the resolution, and you can have a good predictions, you can good analysis. Otherwise, it's very challenging. The skill of the gap, as I explained to you, that the company working for civil engineering, they have like some staff they are employed like 10 years ago. 10 years, they have like a very huge change of the mentality of advancing technology, and this stuff they are not trained yet. The skills, there is a very big gap between the people who implement and the new technology. And also initial investment, so it's to invest in these digital twin models, or what we call industry 4.0, 5.0. So the people, they need to invest on this at different level, not only on the machines, but only on the staff, because this staff will run the machine also. And so it's also a kind of change in the management mentality that is also very challenging. So as a conclusion, as I explained, this is the frontier research. We need to adapt a core budget for maintenance that can be challenged, especially in rapid changing technology environments. Skilled workforces, so it's not easy, as systems become more complex. As I explained to you, when we have data scientists, we cannot find it in the street. These people, this speciality, it's only like a few years ago that we talk about it. So the engineer, they are not used to it. Most of this expertise are based on mathematics, knowing that the level of mathematics it's falling this recent year. So it's really challenging to find the right guys, and so we are still challenging. Integration of the systems. So everybody are talking about Industry 4.0, and I saw lots of factory, they have a robot, and okay, they have a robot, but you know, the guy who worked this factory for 10 years, you put robot, for him is new. He's really, it's like they need to have this, to give him more skills, to train him more to do this. So thank you very much. And the last question, as I told you that this is one of the journals related to the simulation and multidisciplinary optimization. I'm publishing with my colleague, academician, Professor William John from Xi'an also. He's vice president of Xiguda. Yes, or that's my how do you call it? It's very funny. This is the guy who really bring me the first time in China, like I don't know, 2007, and so. Okay, thank you very much, and please let me know if you have any questions.
Thank you, Professor. Any question? Okay.
Yes, sir. Professor Bassett, I had one question about the depth of the crack. How you will understand through the model? Is that maybe the shape of the crack will be some, because I work with the crack on the pipeline.
Yes.
Okay, and then with the vision system I work, but with the depth of that, always we have problem.
Yes.
I think for the cement and the bridge, it will be more complicated to understand. Because shape of the crack on the metal will be some
Yes.
rule of thumb, but with the cement, it will be differential that we don't know that how much in depth of it.
Yes,
How
that's.
do you understand it? Can you give me some?
So it's already there is with my colleague Professor Guangzhou. We have a PhD running on it, and so there is different techniques when you have a crack on the concrete. What we do, option one that was trying to do, we use instead of normal camera, we use like we call it thermal camera. So which means you can follow the temperature. And imagine when you have a crack, you spray it with water. If you spray it with water, what will happen? So you will have, if you take a surface,
The bubble, okay.
so you have the change of the temperature are different between the surface and the crack. So don't think but the problem, this kind of technique, it's not easy. With the drone, you cannot carry a lot of water. So what we do actually, what I suggest actually working is to spray with what we call a cold air or hot air, whatever, we don't care, as soon as we can observe a variation of the temperature on the wall. When we spray a wall on the crack, we can see a crack, we can see, because the dip, the temperature will change depending on the dip. So we can understand and make a better analysis. But it's still, between the idea and the application, we still have time. We still have space.
Nice.
Maybe remote sensing will also be applied to
Yes,
detect the depth of the.
that was nice. I learned one thing for next research. Thank you so much.
Thank you for this informative speech. Thank you so much.
Thank you. Thank you.
Okay.
Okay, so after this in-depth exchanges and lively discussions, the first industry connection activity offline meeting promoting standards on digital and green technologies for ICT, Industry 4.0 and smart manufacturing industry connections activity is about to come to a successful conclusion. On behalf of the organizer, I would like to express our sincere gratitude and high respect to all the attendees, and special thanks to our three speakers for your significant contributions to this event. And thank you to all the guests for your active participation and contributions. It is your enthusiastic dedication that has made this meeting a grand event of ideas and innovations. At the same time, I would like to express my sincerest gratitude to all the hardworking staff and volunteers whose efforts ensure the successful holding of this meeting. Thank you again for your participation and support. Looking forward to meeting you again in the near future to jointly promote the development of technology and academic. Wishing everyone a safe journey back and a bright future ahead. Thank you. you.